Object A is located at 10, 50, 10 meters, and object B is located at 60, negative 40, 20 meters. Object A is moving with constant velocity negative 10, negative 8, 2 meters per second, and object B is moving with constant velocity 12, 10, negative 2 meters per second. State the position vector of each object at time t. So let's look at A, so position vector of A. So we know that initially when t is 0, it's at 10, 50, 10. Then it has this velocity. So every second it's moving negative 10, negative 8, 2. So where t is the number of seconds, negative 10, negative 8, 2. So when t is 0, it's at this initial point. When t is 1, from the initial point it's moved by this vector. When t is 2, it's moved twice that vector, and so on. And in the same way, RB is equal to, starts at negative 60, negative 40, and 20, and then they start at the same time, so we can use the same t. Every second it moves 12, 10, negative 2. We now want to find the smallest distance between the two objects in their subsequent motion and the time at which this occurs. So they're moving along paths like this, and at some point there must be the shortest distance between them of any point on their paths. Now it's a common question, and this is how you do it. What we do is work out the relative position vector. So we'll do RA minus RB. And this relative position vector is called ARB. So what we're going to do is 10, 50, 10 plus t, negative 10, negative 8, 2, take away negative 60, negative 40, 20, and also take away t, 12, 10, negative 2. So 10 take away negative 60 is going to be 70. 50 take away negative 40 is going to be 90. And 10 take away 20 is negative 10. So that's the relative position at the start. Then we're going to want t. So we've got negative 10, take away 12, negative 22. Negative 8, take away 10, negative 18. And 2, take away negative 2, would give us 4. From there, we can read off the relative velocity. That's just this vector here. So negative 22, negative 18, and 4. The shortest distance we're after happens when these two vectors are perpendicular. So we want ARB dot AVB is equal to 0. Now I'm going to use the calculator to help with this. So we're going to solve, and then I'm going to put 0 equals, and then I want to put in this dot product. So dot p. So remember, we need square brackets for that. So our first vector is going to be 70 take away 22t. I'm going to put this in as 70 take away 22x, so that the calculator will solve for it without me having to do anything else. 90 take away 18 x, and then negative 10 add 4x. And then here we have negative 22, negative 18, and 4. And that gives me 3.88 and so on. So what we've solved, remember, is ARB dot AVB is equal to 0, gives us that t is equal to 3.88 seconds, correct to 2 decimal places. Now, what we want is this length here, and this, remember, would be the relative position of the two objects. So what we want at this time is ARB. So if t is 3.88. So this was the relative position. So 70 add this time times negative 22. So that's negative 15.44. And then we're going to want 90 add this time multiplied by negative 18. So that's 20.10. If we go to 2 decimal places. And then finally we've got negative 10. I have to use the other negative, of course, so I don't get just the last answer. So negative 10 add the time multiplied by 4, 5.53, and then the distance we want is the magnitude of that vector, so it's going to be the square root of, let's pop some brackets in there, and let's just drag that down to there. So we're going to want that one squared, add, put some brackets, we'll just drag this one in here, and we'll just square that, make sure it's all under the square root, and then pop some brackets in there, and then we want this one dragged in here as well, and square that, and then we get 25.94, and the units, I believe, were meters. correct to 2 decimal places.